Hello everyone, this is our first presentation of our class, and I wanted to use this opportunity to go through cluster analysis. I'm going to spend a little time talking about a couple clustering algorithms and not going to a huge amount of technical detail about them, but I'll talk a little bit about kind of the different flavors of them, when they're used, why they're used, and a little bit about how they're used. What I would like you to think about, though, is as you're looking through these slides and understanding kind of how k-means, k-medians, and hierarchical clustering work, how would a business use these different tools? Whether it be a small business, a medium business, or a huge business, how can they use these kinds of tools to process their own data and get a better understanding of what they're able to see and able to find in order to innovate their business processes? First things first, why do we cluster? Why do we even do it? It's been around for quite some time and it's a very useful tool. It's useful in the sense that it allows us to take giant data sets and divide them into some smaller structure or some smaller number of groups. So, for example, we might use clustering to identify people or customers or data points or anything like that that show similar patterns on key measures. And in the case of customers, it could be their purchasing patterns. In the case of data points, it could be, gene behavior or something like that. And we want to group them together so we can do things with the groups. For example, like with customers, we could treat the customers differently in the sense that we would market to two different groups of customers in a different way. Or if there's other, divisions of data points, it may require us to take different action. It also allows us to try to find things in large data sets that we wouldn't normally see or even know. And that's kind of the big processing power with the computers. That's what it's allowing us to do, is to identify in data sets in the past, which would have been beyond our scope. It now allows us to identify things that we wouldn't usually have, or we would normally have seen. A bit more about clustering. It's a way of, as we said, a way of grouping together data samples that are similar in some way, which is according to some criteria that we've chosen. It's also, in more technical terms, it's a form of unsupervised learning, which is kind of to say that it's the ability for us to submit a data set, whether it be large or small, to an algorithm and have the algorithm sort of do the work for us. We don't tell the algorithm what to do. We just tell it basic parameters of what it's going to do, and it kind of does all the work for us, dividing our data set up into patterns based on what it is able to find and the relationships it's able to see. And it's also sort of a method of data exploration in the sense that we don't necessarily, again, feed it what we expect to get out of it. We just basically throw a data set at it and said, hey, look at this and tell me what patterns you're seeing based on the parameters I've given you. And it can find stuff that we didn't even anticipate. So it's a pretty cool tool, something that's becoming very useful. On this slide, I've listed a few categories of clusters. The reality is there's more categories, there's more clustering algorithms than you can shake a stick at. And in fact, k-means and k-medians, which I'll talk about later, have a multitude of variations. It just depends on what the statistician is trying to get out of the data set. But we're going to talk about basic k-means and k-medians, and then we're also going to talk about hierarchical clustering. That one has multiple versions as well. It's just I wanted to try to bring a different clustering algorithm in so you could see sort of the difference between k-means and a completely different approach. But like the last bullet point says, there are a ton of other variations out there, all really with the same purpose, and that is to take a data set and divide it into clusters based on similar expression patterns or similar purchasing patterns or the like. So let's start with k-means. Our textbook by John Foreman actually does a really good job using the junior high dance scenario of explaining kind of what k-means clustering is doing. K-means, first of all, the k part is a variable that we set. So we determine what k is. And this might be the only real knowledge other than the similarity metrics and like that we actually feed into the algorithm. And it may be something that we change as we go because we may not have a good idea of how many groups we want to divide the cluster into. Or we may, and we just want it to do the work for us of actually doing that work. It is based on means, which is mean is the average. As we know, mean is calculated of the average. The mean is the mean of the cluster. So we calculate sort of these cluster means, if you will, and those cluster means are calculated by determining the distance of each data point from those clusters. Then we take for each data point, we take the cluster that is the closest, and we determine that data point to be in that cluster. But those cluster means are based on the actual values that we feed into the cluster. So the values of the data points we feed into the cluster are what is used to determine the number of means for those clusters. So we're actually looking at the value. So in the case where it could be customers, we might actually find that we have a customer data file of 5,000 transactions. And those 5,000 transactions could be divided into those that frequently purchase, those that almost never purchase, and those that purchase somewhere in the middle. And we're pretty confident in that. So we'll set K to 3 and then feed the data set into the algorithm. And the algorithm will calculate cluster means for 3 separate groups based on the customer's purchasing patterns, and then determine which cluster each of the 5,000 records is closest to, thereby dividing up the data into those 3 separate clusters. So as I talked about in the previous slide, we'll set K equal to 3 and run the K-means clustering algorithm on that data set. And we may find that we have 2,000 frequent purchasers, 1,000 rare purchasers, and the rest all go in the third cluster. Again, the algorithm does all the work for you, and we can launch 3 different marketing campaigns. Now that we know who's in each of those different groups, we could divide up those groups and then actually, do a frequently more aggressive marketing campaign to those that are frequent purchasers, or maybe take a different approach to those that hardly ever purchase from us to try to get them to purchase more. In this particular example, we pretty much knew what K should be, but what if we don't know what K should be? Sometimes you'll feed in like K equals 4. Let's divide the data into 4 groups. And then you can run the first pass and check your results. You'll know that each data set has been assigned to a particular cluster. And if you start looking at the clusters, you start seeing there's examples of where this could be divided down further, or maybe I divided it down too far. You can adjust your K value. Your K is typically going to be a smaller value. It doesn't make a lot of sense to divide, a data set up into 50 different clusters, because there's not a lot you're going to be able to do with those 50 different clusters. You want to be able to sort of get the most efficiency that you can out of the process. So dividing it up to 3, 4, 5 different clusters, in real practical terms, would allow you to run 3, 4, or 5 different email campaigns to the different groups. And that would make more sense than trying to do something for each of the different 50 clusters if you were to run it that way. So now that we know what a K-means cluster is doing, dividing your group or dividing your data set up into some number of groups, how do you run one? Well, there's a good example in the textbook, although it's pretty complex, but it's a pretty cool example, actually, the way he does it. And he shows you how to run a clustering algorithm on a data set, a K-means clustering algorithm on a data set, to divide that data set into 4 different groups. And then there's various other exercises where he actually has you change it to 5 groups, that kind of thing. But you can follow through the textbook and really get a good idea of what he's doing there. There's also a number of different statistical packages, such as SPSS and other statistical packages, that all have various versions of clustering algorithms. Some development companies actually build their own clustering algorithms, or they'll build a routine that does the clustering algorithm for them. You can also actually, both in Python and R, you can run clustering algorithms. R programming language, which we'll look at more, not maybe at this level, but we'll look at more later on in the course, has a K-means function as well. I would encourage you to review the text example. If you can, download the data set and just walk through it. He walks you through step by step, each step that you need to do in order to actually run a K-means cluster on his data set. The only downside is that he's actually done it all for you. So when you go to look at it, you'll see everything he's done. And I think there's a lot of use in if you were able to take kind of an example of the data set and walk through it all. There's a lot of use in that. It gets you kind of a better idea of some of the functions that are in that spreadsheet. But anyway, it's very useful. I don't expect you to know it inside and out, but it's good for you to get a feel for how it works. One of the things we're going to talk about a lot in this class, with this being data-driven innovation, is the whole concept of big data. And K-means clustering can be very useful with a big data set, in the sense that it allows you to sort of divide up a big data set into some number of clusters based on the parameters that you've given it. And that can actually reveal things you may not have seen before, or you may not have expected in the data set. You may find that certain things are grouping together based on certain factors, and it's a surprise to you. So K-means is one of many functions that we'll be looking at when we're talking about big data, because big data is really becoming a huge, so to speak, huge thing in the field out there as more and more companies are gathering their data sets and learning what they can do when they're able to sort of go through the data set, mine out the bits and pieces that are very useful, and then continue to sort of use that data to expand their customer base. Here are some examples of things you might be able to use k-means clustering for. We've already seen a couple examples of examining client lists and tracking purchase behavior. So if you were to look at 5,000 or 10,000 records and want to be able to divide that into some group based on their purchasing behavior, you can do that with k-means clustering. But you can also use it to sort of conduct research about demographics and population groups, how are population groups differing on certain parameters, and maybe even counties. If you're looking at, I think there's something like 3,000 or something like that counties in the United States. If you wanted to look at the different demographics of those counties and group them together based on certain factors, that could be done in k-means clustering as well. Scientists often use k-means clustering and other clustering algorithms to identify kind of things such as if you're treating a population with a drug, what kind of side effects might be presenting themselves, and what other factors would some of those individuals share if they're experiencing side effects or not experiencing side effects. And then data mining. I mean, data mining is another thing that we talk about when we talk about big data. And basically what that is just the ability to go to a big data set and find value in that data set, find things in that data set that are useful that we may not have known were even there. So k-means clustering is a good way of doing that, because if we go through and we divide a data set up based on certain parameters into, say, 5 clusters, what are we finding in those clusters? And what similarities did we find that we may not have expected to find? Statistical or more statistical things that refer or can be associated back with k-means clustering. You can look at it as an algorithm divides n observations into k clusters. N observations are the number of records that you have. So whether your data set is 5,000 or your data set is 10,000, n would be 5,000 or 10,000 in those cases. Into k clusters, you determine what k is going to be. The determination of cluster placement is determined by the distance of a data point to the mean of the cluster. And what that basically means is we are going to determine which cluster each data point is going to go into based on its distance from that cluster's mean. So data points get put into the cluster that has the closest mean. The mean of the clusters is determined by multiple cycles of the algorithm. So what the algorithm is going to do is it's going to pass through the data and it's going to start to identify what those groups are, and it's going to calculate what the means of each of those groups should be. And then it's going to continue to cycle through over and over and over again to make increasingly small adjustments to those cluster means, so that it can become as accurate as possible and identify as accurately as possible which data points should be associated with each of those cluster means. So the cluster will stop when there's no more adjustments that are needed. There are a whole bunch of distance metrics that can be used to determine when we say that we want to put a data point close to the cluster or the cluster's mean. Well, what are we using to determine that distance? And there are a bunch of different sort of flavors to determine that distance. The example in the textbook uses Euclidean distance, which is basically, if you took algebra in high school, it is your Pythagorean theorem, and you'll recognize it when you read it in the textbook. But it's basically how we are determining how far something is from the centroid of the cluster. And because the algorithm calculates means, the k-means calculates means, is going to be impacted by high variability in the data. And this can compromise the results. We'll go into that more in a little bit. About how variability is going to impact the accuracy of a k-means cluster, let's go over some things which you may already know, but it's worth revisiting. First off is outliers. An outlier in a data set is something that is kind of way off. It's kind of something that is much higher or much lower than what we would, what the rest of the data points are looking like. And I've given you an example here where we have some number, 6 numbers, 21, 42, 36, 15, 57, and 155. And that last number is an outlier because it's so much higher than all the others. What that's going to do is that's going to pull the average up. So you're going to get an artificially higher average just because of that one single outlier. But that's just the way mean works. Mean is subject to outliers, and it's always going to be impacted by outliers. And it's also going to calculate, so in a k-means clustering situation, since you're working with mean, when you have outliers, it's going to impact the calculation of the cluster means. and could also impact your results. So the placement of the cluster mean is going to be determined by the data points that are part of the data set. If you have one or multiple outliers in that data set, it is going to impact your mean and thereby impacting your centroid and impacting the placement of your data points. So k-means does suffer from that limitation, although it's usually used because those data points, the outliers that are data points, are meaningful. They actually are real measures, and we do want to calculate them in the mean. Noise is random data that doesn't really do anything. It's just sort of, it's kind of like static on your radio. If you're trying to find a radio station and you're static, and something, finally somebody breaks through, a voice breaks through, that's finding the signal in the noise. And the noise is just staticky, useless data that doesn't have any discernible pattern. Yet, if there's a lot of it, it'll become a factor in determining the mean. And so it's something that we have to take into account. On mean, sometimes it's better to use median. And let's talk a little bit about what median is. First of all, as we know, mean is the average. So when we are doing a k-means clustering, we are looking at the data points and we are calculating clusters based on the average value of those data points. So we basically create a centroid based on the average of the data points. But if we have noise or we have a good number of outliers that maybe are less meaningful, our averages can get thrown off. So the midpoint, or using the median or the midpoint, is a way around that. This works pretty well when, if you were to remove all your outliers and noise, your average and your midpoint would be pretty close to the same. So it corrects for noise, it corrects for outliers. And it creates the centroids of your clusters based on the midpoint and not necessarily the average. The midpoint is if you sort all your data values, or the median is if you sort all your data values and then take the middle one. If you have an even number, then you have to sort all your data values and take the average of the two midpoints, and that would be your median. So k-medians basically works the same way, except for it uses median instead of mean. As I said, it protects the results from outliers and noise, but it can give less accurate results if your outliers are actually meaningful data points and you want to be able to use them. So it has to be sort of, you have to use your best judgment as to whether or not it's best to use mean or median. There are a ton of clustering algorithms out there, and there's flavors of clustering algorithms. So you might have k-means, you could have several different flavors of k-means, you have k-means with multiple different distance algorithms. So it's just, again, finding out which ones you want to use, and most of these are the purview of statisticians, and we're never going to care. But I did want to point out one clustering algorithm that is quite different and quite useful, actually, and that's the hierarchical agglomerative clustering algorithm. We won't worry about the rest of them, but I'll go a little bit into the hierarchical clustering algorithm so you can get an idea for how it works. For agglomerative clustering, we don't give it a K. We don't really give it much of anything except for the metrics we wanted to use in order to make comparisons. So we will begin the clustering process by putting every single data point in its own cluster. Then the next step, and we'll do this multiple times, multiple iterations going through this algorithm until, again, it makes no sense to continue going. But the first thing we'll do is we'll find the data points that are the two data points that are the most similar, and we'll group them together. And they will be indicated as being very similar by the way they're put together on a dendrogram. There'll be two branches on a tree that'll be very, very similar. Best way to sort of picture that in your mind is to think about it as a sort of an upside down tree, if you will. And two data points that are very similar would be very, very small distance branches away from each other. Then we'll go through that cycle and do it again and again and again until we've accounted for all of the data points and we've built this dendrogram that shows all of the data points and the placement of all of the data points based on how similar they are to each other. It's called bottom up because we start with the single data points, and every single data point is in its own cluster, and we start grouping those clusters together. So that's where the agglomerative method comes into play. Dendrogram from a hierarchical agglomerative cluster, and what you can see in this example is you've got 16 data points, and those 16 data points were initially all put into their own clusters. And then what we did is we found and organized the data points based on similarity. The height of the conjunctions indicate the level of similarity or the level of difference. So a very low conjunction might be suggestive of there being the data points being very, very similar. And then the higher ones are where there's a lot of difference. You'll notice in this particular dendrogram, we've got what looks to be sort of 3 clusters. And if this was run with a k-means cluster, we might actually feed k in as 3. But you've got your data points that seem to be grouped on that branch on the left side, and that's going from items 1 through 10. And then you've got the data points 5, 6, 11, and 12 that seem to be branched on a different branch. And then over there, you've got 13, 14, 15, and 16, and those data points are all kind of thrown off on a different branch. What that would suggest to us is that those data points from 13 through 16 are expressing very different behavior, or very different sort of patterns than the ones that are over on the other branch. And that's really what a hierarchical cluster does for us, is it organizes our data points based on the behavior we're looking at, whether it be customer patterns or whatever, into a tree like this, and gives us some similarity metrics that allow us to see just how similar certain expression patterns or behavior patterns are. You can see from the example on the previous slide, hierarchical agglomerative clustering is quite different from k-means or k-medians. Remember, in k-means, we calculate the means of clusters and then use a distance measure to find the closest cluster. So we're really looking at the similarity to the cluster mean. In k-medians, we calculate the median of clusters and then use a distance measure to find the closest cluster. Also similarity to the cluster median. But in hierarchical, we are really comparing each data point to all the other data points to find those that are most similar and then build a dendrogram based on findings and similarity. Bring us to use an example, and I'll use an example from my previous life when I worked in biotech and used to actually look at examples where we would pull in multiple different lung tissue samples. Some were various different kinds of cancer, and then there was one sample that was a control that had no cancer in it at all. And in these samples, what we were doing is we're tracking the expression patterns of several thousands of genes, and we wanted to see which genes were doing what. And we were tracking which ones were active and which ones were not active. So we used the hierarchical agglomerative clustering to allow us to see across these 50 different lung tissue samples which genes were expressing themselves in a similar pattern and which genes were actually very different. And so that really helped the researcher to identify which ones are active in sort of unison and which ones are really kind of not really doing much at all. And that gives the researcher a target for treatment. So in the particular case of lung cancer, when you find those cells, or those genes that are active in the cancer that are not active in the normal tissue, then you have a potential target for something that you can actually sort of try to control, maybe thereby impacting the cancer. And that was all done through hierarchical clustering. It was a very large cluster with many, many data points, and it worked very, very well. An example of where clustering may be playing a role, and that is, I'm not saying that they're using k-means clustering for this, but they could use k-means clustering for part of this, probably using something that's far more complex. But on Amazon.com, you'll often see people who bought whatever product you're looking at also bought these other products. I don't think I've ever looked at an Amazon page where they didn't show me 2 or 3 other things that was associated with the people who bought what I was looking at. So how do they know that? And did they use k-means clustering? Well, they could have. They could have actually taken a data set with tons and tons of customer purchase patterns, and they could have identified those customers that had things that were the same, or those products that were the same, that had similar purchase patterns. They could have also used a hierarchical cluster, but as I indicated, they're probably using a number of different statistical processes built into algorithms to get those results up very quickly. But the data that we're looking at whenever we go to an Amazon.com site and when it's showing us the stuff that others also bought is based on millions of records of data. And when you talk about big data, that is big data, and there's tons of it. And so they really need to have, algorithms and statistical processes that can go in and look at those records, identify what those relationships are, in order to be able to present that to the customer when the customer is purchasing. You'll also know that, or notice if you've gone into Amazon, if you do a substantial amount of purchasing from Amazon, what they present to you oftentimes changes based on what you buy. And it is their ability to sort of track your records and understand what you're doing and compare that to what everybody else is doing and determine, what things they should be presenting to you based on your most recent interests. couple things I want you to remember. First of all, cluster algorithms divide data sets into groups. That is their primary function. That division is usually based on similarity. So I'm going to want to find all of the people in my sales database that did something. But it could also be based on dissimilarity. So I may be able to identify groups where things are very, very different, and that could be very useful as well. 3 different clustering algorithms that we looked at. K-means allows you to divide your data into K groups based on each data point's distance from each of the K clusters means. So first off, we calculate the K clusters means. We go through several iterations of the algorithm to refine those means. Those means are actually based on the value of the data points you fed in, and then the cluster assignment is made based on the lowest distance. So whatever data point, if you've got data point 492, you're going to look at all of your cluster means and you're going to determine which cluster it belongs to based on the shortest distance to any one of those clusters means. K-medians basically does the same thing, but instead of using mean, it uses median. And the reason why we would use K-median is if we have really noisy data or we have a lot of outliers that could throw your means off. And then the hierarchical clustering algorithm organizes your data according to how similar each data point is to all of the others. And that builds a dendrogram showing similarity in the strength of those relationships. Well, I don't expect you to know, here's what I expect you to know. What are clusters and what are they for and what you can do with them and when to use which ones. So just have an idea of what a K-means K-median cluster is, that there are many different other kinds of clustering algorithms out there. The most common other kind of algorithm is probably the hierarchical clustering, where you're looking at similarity of all data points when compared to each other. But again, there's more flavors than you can count. I don't expect you to be able to actually run clusters though. I'm not going to expect that we do that here in this class. That would probably be something that would take us more time than we have. So it's nice if you want to take a look at it. John Foreman's book gives you a very good example in Excel. You can also poke around in R when we start getting more into R and see that there's a K-means clustering function in R that allows you to sort of build your own clusters, but it's pretty complex, and I don't know that we're going to get into that level of detail. That's just kind of bonus work if you want to do it, but I'm not going to expect you to know how to do it. I do want you to know what clusters are and that they can be very useful in many different business situations. So I wanted to go through with the K-means, K-median, and hierarchical clustering stuff. I will recommend that you read the Big Data book. The Big Data book gives you kind of a really good idea of sort of the social and professional implications of where this big data field is going. And if you're not familiar with big data, that book is perfect. It will tell you everything you need to know. I would also recommend that you read Foreman's Introduction to K-means. That's chapter 2. He quickly gets into sort of, well, he talks about basically conceptually what is K-means clustering, and then gets into a pretty hairy example, which is, I think, is really cool actually. But read it until you get an understanding of the clustering algorithm. And then while you're doing that, imagine how businesses can put these to use. Foreman says he wrote his book because he wanted to be able to give people who are data-minded or inclined in that way the tools and ability to be able to run things like Bayesian analysis and clustering algorithms and stuff like that, all that stuff that we'll talk about. But just think about, just from a general standpoint, how can businesses use this information or these processes to innovate their business processes and run more efficiently? Until next week, enjoy your week.